Hello everyone, welcome back. So in this video, we are going to understand the Leetcode problem number 1415. It is saying the kth lexicographical string of all happy string of length and we have to find, right? Lexicographical, it's a kind of let's suppose the alphabet ABC we have, right? So the alphabet lexicographical means it's having some value, and based on that this is in ascending order, right? Like that we can say that. So it's kth lexicographical string of all happy string of length we have to find. We'll discuss more what is this and how we are going to solve this problem. Okay, so very first let's try to understand what the question is saying here. Is we have given this example, we have given n equal to 1 and k equal to 3, means we need to generate happy string of length n using the character. Let's call the characters are some character, let's suppose ABC, let's suppose. Okay, so it is saying that a happy string is a string that consists of letter of the set ABC, and s at I is not equal to s at I plus 1 for all the values of I from I to stroke length. We can say that like that we can say that. Okay, for example, we have a string ABC, we have AB, we have B, we have ABC, like that we have all our happy string, and string AA, BAA, ABBA are, these are not happy string. Okay, so when two given integer we have given n and k, we have to list all the happy strings of length n, and this should be the sorted the lexicographically order. As I told you, A, B, C, these are the sorting order, right? So we have to return the kth string of the length of the return, or return it's an empty string, like that we have given. Okay, means if we have given n, we have given k, we have given, right? Means we have to find the number of happy string using this n, and you have to use the character A, B, C, D. You have to use A, B and C, right? So a string is happy if no two adjacent characters are same. This is what the question is saying as per the next value we have, right? Means two string means two adjacent, right? We call adjacent. Two adjacent values are characters are not same. In that case, the string becomes happy strings. Let's try to understand what I'm trying to say here is, let's think that we have given some valid happy numbers I'm talking about. Let's call we have A, B, means these two are not consecutive, right? And both are not same, right? We'll say A, C, then we'll say B, A, then we can say B, C, C, A, C, B. So if these kind of values we have, these are called happy string, right? And these are valid case. Okay, let's think that we have some value. Let's suppose A we have, B we have, C we have, A we have, A we can say. So if any letters are repeating, right, these are repeated adjacent value, right, characters, and these are not happy string, but these are happy strings. I hope you understand everything what I'm talking about here, right? Now let's think that so after generating all the happy string of length n, right, that we have given, let's suppose n string we have given, right, n is a length we have given, and if we generate all the happy numbers of length n, means we have to sort them with the lexicographical order. This is called dictionary order, we can also say. Lexicographic means nothing but dictionary order, and then we'll return the kth string. If fewer than k string we have, we will return nothing but empty string we will return, as it is saying that, right? Let's think that with the example. Okay, let's think that we have given some input n equal to, we can take 3 and k equal to 9. Example number 3 I'm talking about, this one. Okay, this is very important. Okay, so we will generate all the happy numbers of length n equal to 3, right? Very first, what we should do, we should start building the string. Possibly we can take the character A, B and C, what the question is saying that, right? So if we'll take the possible characters A, B, C, and we will start building. So very first what we will say, okay, let's start with A. So we'll write A. Next character cannot be A. A should not be the next character. Next character can be B and C. These two can be possibly, there are possibilities that we can write B and C but not A. It means what? It means if the next character cannot possible A, it means B and C is possible. Means the options we have is, if we'll start with the A, right? Means the next character could be AB, right? It will become AB or AC, because this is common, but only there are two options. Either you will use these two but not the A. So these two will become the valid one, right? So if we expand AB, let's suppose now we will expand the AB. So if we expand the AB, then A, B we already have, right? There is a chance that after the next character, what is not possible? B is not possible, but A is possible and B is not B, C is possible, right? Like that we can say. It means if we expand this one from using these rules, means what are the characters will become here? We'll say A, B, A. Another character will be what? A, B will remain same, only here it will become C. So these two become the possibilities, right? If we'll expand this A and C, means what is the possibilities there? We cannot repeat A. No, we can repeat A, and B we can repeat, but C we cannot repeat, right? So in this case, if we'll use this concept, what are the what are the string will become, right? AC, AC will remain same, right? What will come? Either A will come or AC, B will come. So if you see here, this and this, it's when we start with the A, these are the possible string is possible here, right? So when we write n equal to 3, means we want some happy numbers. What are the happy numbers is possible? These and these are the possible when we start with the A. Similarly, you can start with B and C also, right? So let's assume that some of the given things we can start from here, we can collect from here also, right? Let's think that we have seen that when we start with the A, we got B, and then options we got what? A, right? Next thing that we have, AB will remain same, AB. What will come? C will come. B will not repeat, right? B will not repeat, A and C will come. Third thing, let's suppose we talk about A and C comes, there we got what? C, after C it come A, the A, C, B will come, right? These are the possibility, right? Let's think that if it start with B, what will come? B, A will come, then there is possibility C will come, B, A will remain, the A will not come, it will come B, like that, right? When it will start with the B, A, then B, C, B, C we can also write, right? B, C, A will not, B will not come, but C will come, right? C we can say, and then another C will also come. Then after C is coming, what is coming? A will come and B will come. So we can say 5, 6, 7, 8, 9. Let's suppose next that we will create is BC is done. Let's start with the C. Then we possibility is that we can start with CA. Okay. So very first, when BC we have already completed, right? Yeah. Then it will come CA, right? Then CA, there is two possibility, either CA it will come with B or C, correct? Similarly, we'll say okay, now start with the CB. After CB, what should come? A should come. After CB, what should come? C will come. So these are the possibility that we can say 9, 10, 11 and 12. These total 12 lexicographic string will come, that become happiest string. So if you see that these are the happiest string, right? Now what is very important here is to find the total number, right? You can say. So if you see the lexicographically, kth lexicographically string we have to find. In this case, what will come? K equal to 9 we can talk about, right? This one. So when K equal to 9, right? K equal to 9 will say that this is what our question is saying, that K equal to 9. We need the kth. So kth is nothing but 9th. Means 9th. What is 9th here? This is the 9th is here. Okay. And here when kth is 9, we will get what? CAB, right? And this is our answer. And if you see here, this is the answer here. I hope you understand this, and how we'll build this, that is different thing, but you understand the problem statement. So basically it's a kind of if you remember, backtracking, right? Backtracking concept. Okay, this is based on backtracking. if you know the backtracking tree, this is based on the backtracking tree. Okay, very first, when it starts with A, it goes to either AB or it goes to AC, correct? Further, it goes to ABA or it goes to ABC, or if it starts with the A, these two possibilities there. AC will remain, either will come B or AC, B, A, C, B, C will not come, means A will come, right? Like that. Similarly, if nothing comes here, let's suppose, means what will come? It will come, B will come, right? So let's say B is coming. From the B will say BA. Like that, you will maintain the tree, right? A start with the C. Similarly, these are the strings we have seen already, right? So each level will represent a string length, right? So the concept is that we think of DFS approach, right? To maintain this tree, where you will each time you will count the length of the character, and if it will match with the 3, right, we will get all these 3, right? We'll collect all and then we'll find the kth one. Let me show you the code, then you will understand clearly. Okay. Okay, let me increase little font. Yeah, so if you see here, very first we know that we have to use the get happiest string, right? You will use n and k, right? And what you need to do, you need to do the DFS, because you will start with the empty one, n and k. So each time you will find its length, current length, then you will increase the count plus, and if all the if you get the count equal to k, it means the current value will be our answer that we have seen, right? CAB, that we have got the answer. Otherwise, we'll maintain this, we'll get ABC characters, right? And if the length is greater than equal to 0 and not equal to the current length, right, it means what we'll do, we'll keep doing the DFS, we'll keep adding the character, next character we'll keep adding here, okay, and we'll do the DFS like that. We'll keep doing that. Otherwise, if it is empty, we'll return the result. So it's very easy if you understand the approach that we are talking about. If you have any doubt, let me know in the comment section. I hope you are understanding the recursive DFS approach, where we maintain the backtracking. So this is the concept of backtracking, where we will start with the empty string, and then we will go with the very first A, when start with the A, when start with the B, and start with the C. Then you will expand the AB with the ABC, AB, A, like that. You will keep expanding that, okay? And you will finally, whenever you will get the count k, right, because the kth we need, you will return the result, okay? I'll put this code into the comment box. Do try run and do some debug. Let me know in the comment section if you like this video, and keep subscribing and supporting ExpertFunda in case you are new in the ExpertFunda. Otherwise, share with your friends and like this video. Thank you so much.